What is the jacket on your back actually made of? Not in the sense you already know, not leather, not cowhide, in the precise physical sense. Because the material you're touching right now began as a raw animal skin, pulled from a carcass within minutes of slaughter, packed in salt, shipped across thousands of miles, then submerged in acid, rotated inside an industrial drum for the better part of 2 days, and dried under vacuum pressure before anyone considered it finished. Every piece of leather on Earth, every jacket, every car seat, every designer bag went through a version of that process. And almost nobody who owns one has any idea what that process actually looks like. This is what it looks like. Every hide used in leather production is a byproduct of the meat or dairy industry. The animal was not raised for its skin. But once slaughter occurs, time becomes the enemy immediately. Fresh hide begins to degrade the moment it leaves the body. Bacterial activity starts breaking down the collagen within hours, so the skin must be removed quickly while body heat is still present in the tissue. From that moment, the clock is running. The rawhide is salted heavily, not lightly preserved. Packed in salt, the kind of aggressive treatment designed to stop biological decomposition in its tracks and keep the material stable enough to survive transport to a tannery, which may be located in a completely different country. That salt-preserved hide represents between 40 and 50% of the total cost of the finished leather. The single most expensive component of the entire production process is the thing that still looks nothing like leather. When the hide arrives at the tannery, the first machine it meets is a large rotating drum connected to an electric motor. Its job is simple: to shake the salt free from the surface of the hide. Once that's done, the hide goes into a soaking drum filled with water. This rehydrates the material and flushes away the remaining salt, blood, and surface contamination that accumulated during transport. What comes out is a clean, wet, pliable animal skin, still recognizably organic, still completely perishable. Next comes liming. The hides are submerged in an alkaline solution built around lime, and this is where the first significant transformation begins. The lime loosens and strips the hair from the outer surface of the hide. More importantly, it begins to open the internal structure of the collagen fibers, swelling and separating them so that the tanning agents applied later can penetrate deeply and evenly through the full thickness of the skin. Without this stage, the chemistry that follows can't work. The hide would tan on the surface and remain raw underneath. Once liming is complete, the hides are baited, treated with enzymes that soften the material, and then pickled, meaning they're submerged in a solution of salt and acid. The salt is there to buffer the hide against the shock of that sudden acidity. The acid itself is doing something precise. It's conditioning the collagen at a chemical level, preparing it to receive the tanning agents that are about to be worked into every fiber. Degreasing follows, using solvent or water-based systems to strip any remaining natural fats from the hide before tanning begins. The material at this point is as prepared as it can be. What happens next is irreversible. Tanning is the moment the hide stops being an animal skin and becomes leather. The chemistry permanently alters the structure of the collagen fibers, making them resistant to the enzymes that bacteria and fungi use to break down organic matter. A raw hide left untreated will rot. A tanned hide will not. That single chemical distinction is the entire basis of the leather industry. Two methods dominate. Vegetable tanning, the older technique, uses tannin extracted from tree bark. It is slow, taking weeks or even months for the highest quality goods, and it produces leather with a warm, natural character that develops a patina with age. Chrome tanning was developed in the 19th century, and today it accounts for more than 80% of global leather production. It's faster, more consistent, and produces leather that performs reliably under prolonged use. Both methods take place inside large rotating drums where the tanning liquors, the chemical solutions carrying the active agents, are worked slowly and continuously into the full depth of the hide. Technicians make regular cross-section cuts across the hide to check penetration. The process does not stop until the color reads even all the way through. Chrome tanning produces what the industry calls wet blue, a pale bluish-gray hide that is now technically leather but bears almost no resemblance to the finished product. Vegetable tanning produces a light brown. Either way, the transformation from raw skin to stable material is now permanent. The leather is then split. A precision machine cuts the hide horizontally into two distinct layers. The upper layer, the grain, carries the original surface texture of the animal's skin and is used for premium goods. The lower layer, called the split, goes into furniture, suede, and lower-grade applications. After splitting, a separate machine fitted with sharp blades passes across the underside of the hide, shaving it to a precisely even thickness across the entire surface. Uniformity at this stage determines quality at every stage that follows. The leather returns to the drums for retanning, a second round of treatment, using vegetable tannins, synthetic resins, or a combination of both, depending on what the finished product will need to be. Firmness, fullness, and the way the leather responds to touch are all calibrated here. Dyeing follows. The hides go into tanks of water carrying acid dyes, and the color is tested repeatedly until the exact target shade is confirmed throughout the material. Once color is locked in, fat liquoring reintroduces oils and fats back into the hide, because tanning and dyeing strip the material of its natural suppleness, and without this step, the leather would be stiff, brittle, and unable to flex without cracking. The oils determine how the leather stretches, how it breathes, and how it holds up against moisture and repeated stress. The wet processing is now complete. The leather is dried, either under vacuum pressure between heated plates, or stretched across frames and moved through an industrial oven. In both cases, the hides spend approximately 24 hours hanging from a slowly moving suspended chain, completing the cycle. What emerges is dry, slightly stiff, and not yet finished. The fibers are loosened and softened using machines fitted with vibrating cylinders. The surface is buffed with abrasive rollers. And then the finishing process begins, the stage where leather acquires its final identity. Depending on its destination, it may be embossed with a pressed pattern, given a polymer topcoat for durability, tumbled to produce softness, or treated with nothing more than wax and cold rolled for a natural sheen. Automotive leather and a pure aniline jacket may have gone through an identical process up to this point and emerge looking and feeling like entirely different materials, because finishing is where the variables diverge. Every specification, texture, color, depth, surface protection, flexibility, is a deliberate choice made at this stage. And behind all of it is a cost that never appears on the price tag. 1 ton of rawhide generates up to 80 cubic meters of wastewater, turbid, foul-smelling, carrying chromium concentrations of up to 400 milligrams per liter and sulfide levels approaching 800. Some of the finishing chemicals used in the process, formaldehyde among them, are recognized carcinogens associated with damage to the eyes, lungs, liver, and kidneys. The tannery workers and the communities surrounding industrial tanning operations carry the environmental and health burden of a process that the person buying the finished product will never see and rarely considers. From salted rawhide to finished leather takes anywhere from a few days for a chrome-tanned fashion piece to several months for the finest vegetable-tanned goods. Every jacket, bag, shoe, sofa, car seat, and steering wheel in the world went through a version of every stage described here. The material feels simple, familiar, almost natural. The process that produced it is one of the most chemically extreme industrial transformations in modern manufacturing. And the distance between a dead animal's skin and the thing hanging in your wardrobe is far longer and far stranger than it appears. If you found that process as remarkable as we did, subscribe to Storyline Unknown. There's a lot more where that came from.